Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a problem on pressure due to two fluids contained in a circular tube. The question is as follows. A circular tube is placed in the vertical plane as shown in the figure. It is half filled with two immiscible liquids of densities d1 and d2 in such a way that each liquid subtends an angle 90 degrees at the center. The radius joining the interface makes angle theta is equal to 15 degrees with vertical. Then find the ratio d1 by d2. Before proceeding to solve the problem, let us recall the related concepts. Consider two immiscible liquids of densities d1 and d2 contained in a cylindrical tube of area of cross-section A. The respective heights of the liquids are h1 and h2 as shown. Now, weight of the upper liquid is W1 is equal to AH1D1G and weight of the lower liquid is W2 is equal to AH2D2G. Therefore, net force on the bottom of the tube is F is equal to A into H1D1 plus H2D2 into G. Therefore, pressure at the bottom of the tube is P is equal to force divided by area, which is equal to H1D1 plus H2D2 into G. It may be noted that fluid pressure is independent of the shape and size of the container. It depends only on the height of the liquid column and its density. Now we will derive a trigonometric relation which will be needed to solve the problem. We have tan alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha into tan beta. Putting alpha is equal to 45 and beta is equal to theta, we get tan 45 plus theta is equal to tan 45 plus tan theta divided by 1 minus tan 45 into tan theta. Putting tan 45 is equal to 1, we get tan 45 plus theta is equal to 1 plus tan theta divided by 1 minus tan theta. Putting tan theta is equal to sin theta divided by cos theta and simplifying, we get tan 45 plus theta is equal to cos theta plus sin theta divided by cos theta minus sin theta. Now we are in a position to solve the problem in the question using these concepts. First, let us understand the figure. POE is the vertical diameter of the circular tube. AOB is the diameter joining the ends of the liquid column. The liquid of density D1 is contained in the section AF and the liquid of density D2 is contained in the section FB. It is given in the question that each liquid subtend an angle 90 degrees at the center. Therefore, we have angle AOF is equal to angle BOF is equal to 90 degrees. Now, OF is the radius joining the interface of the two liquids. It is given in the question that it makes angle theta is equal to 15 degrees with vertical. Therefore, we have angle EOF is equal to theta, which is equal to 15 degrees. From geometry, it follows that all the marked angles are each equal to theta is equal to 15 degrees. Now consider the bottommost point E of the tube. Let the pressures on the left and the right of E are P1 and P2 respectively. Therefore, for the equilibrium of point E, we have P1 is equal to P2. Let the pressure of air inside the tube is equal to P0. Then P1 is equal to P0 plus pressure due to liquid of density D1 contained in the section AE of the tube. Now height of the liquid column is equal to CE. Therefore we have P1 is equal to P0 plus CE into D1G, but CE is equal to OE minus OC, which is equal to R minus R sin theta, which is equal to R into 1 minus sin theta, which gives P1 is equal to P0 plus R into 1 minus sin theta into D1G. Similarly, P2 is equal to P0 plus pressure due to liquid of density D1 contained in the section EF plus pressure due to liquid of density D2 contained in the section FB. But height of section EF is equal to DE and that of section FB is equal to PD. Therefore we have P2 is equal to P0 plus DE into D1G plus PD into D2G. Now DE is equal to OE minus OD, which is equal to R minus R cos theta, which is equal to R into 1 minus cos theta, and PD is equal to PO plus OD, which is equal to R sin theta plus R cos theta, which is equal to R into sin theta plus cos theta. Putting these values, we get P2 is equal to P0 plus R into 1 minus cos theta into D1G plus R into sin theta plus cos theta into D2Z. Equating P1 and P2, we get P0 plus R into 1 minus sin theta into D1G is equal to P0 plus R into 1 minus cos theta into D1G plus R into sin theta plus cos theta into D2Z. Removing P0 from both sides, we get R into 1 minus sin theta into D1G is equal to R into 1 minus cos theta into D1G plus R into sin theta plus cos theta into D2Z. Dividing throughout by RG, we get 1 minus sin theta into D1 is equal to 1 minus cos theta into D1 plus sin theta plus cos theta into D2, or D1 into 1 minus sin theta minus 1 minus cos theta is equal to D2 into sin theta plus cos theta, which implies D1 into cos theta minus sin theta is equal to D2 into cos theta plus sin theta, or D1 by D2 is equal to cos theta plus sin theta divided by cos theta minus sin theta. Using the trigonometric relation from equation 2, we get D1 by D2 is equal to tan 45 plus theta. Now theta is equal to 15 degrees, which gives D1 by D2 is equal to tan 45 plus 15, which is equal to tan 60, which is equal to root 3, which is the answer to the question.